Welcome back, Math 110. Let's continue with lesson 3.4, and we're going to start working with some inequality notation this time, or review and work with some. So let's get started. So inequality notation in algebra is typically used to represent an interval of numbers. For example, the set of numbers that are more than 10 is an interval. We could represent that in inequality notation by x greater than 10. So if we drew out a number line and marked off 0, the negative numbers, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we'd start at that point 10, but not include 10, and then mark off all the rest of them. So there are basically two skills you need to be comfortable with: interpreting the meaning of an expression in inequality notation, and the opposite, writing an expression in inequality notation when an interval is described. So the set of all numbers less than or equal to negative 5 can be written as x less than or equal to negative 5. So this is smaller numbers. And on the number line, these are the negative 6, negative 7, negative 8 are smaller than negative 5. So the more the negative, the smaller the number. The set of numbers that are between 6 and 12 can be written as 6. This is smaller than the numbers x up to the point that 12 is here. So it's 6 less than x, x less than 12 is called a compound inequality. Always used to describe an interval between two specific numbers, and you should never write a compound inequality with both a less than and a greater than. So this is kind of backwards of what you would expect. So a bigger than this but less than that should not be, is what they're saying. To be on the safe side, always write the smallest number first, then left, then your choice of the variable, then a number, then the largest number in the interval. So if we did it this way, these would be x's bigger than this thing, so it wouldn't work out correct. The expression t greater than or equal to 8 represents a set of all real numbers that are 8 or greater. T is bigger than, so we could write this either way. 8 is less than or equal to t, or t greater than or equal to 8. So we can swap those as long as we've got the small side and the large side goes along correctly. The expression y is less than 4 represents the set of all real numbers that are less than 4. So 3, 2, 1, 0, and then continue on with the negative ones. Here's another compound inequality, negative 3 less than or equal to x. So this includes the negative 3. Negative 2, negative 1, 0, all of those decimal numbers in there, up to 2, but not including 2. So here are some of the terms commonly used to describe inequalities. Used to represent, here's what it is: greater than, strictly greater than, more than. Less than, not as much as. So this is for the strictly less than. Greater than or equal to, at least, no less than, a minimum of. So these are all the same expression. So greater than or equal to 10, at least 10, no less than 10, a minimum of 10 would all be represented by this. Less than or equal to, so x less than or equal to 5, x less than or equal to, let's say 10, at most 10, no more than 10, a maximum of 10. So we're also going to look at some simplifying algebraic expressions, so we'll need to look at that. When we are doing simplification, at times we need to be able to just expand everything out so that we can group together. So here we've got parentheses, and this means 2 times the quantity of x plus 4 minus 5x. So to simplify this, we're going to need to expand this expression, distribute the 2 over the expression inside the parentheses. So 2 times x plus, so plus 2 times plus 4 is plus 8 minus 5x. And then we can group this. 2x minus 5x is minus 3x plus 8. And here we have a 4y plus 10, and then this expression. Here we've got to consider this to be a negative 1. So we need to have a negative 1 times 3y. That makes that a negative 3y. And then a negative times a positive is a negative 5. If this had been a negative, that would have turned that into a positive. So we switch the signs of everything as we distribute through. Now we can group 4y minus 3y is y, 10 minus 5 is 5. So here is some prep skills questions. Let's switch over and I'm going to expand these out. Let's see if we can work here. So hold on. I'm going to go over to my OneNote. And let's see if I can go over to the side and kind of work these through. So this one right here, I'm going to go right out here, and I'm going to say these are all the real numbers that are at least 17. So x needs to be bigger than or equal to 17. All the numbers, so this could be 17, 18, 19, but at the very least 17. Here, we're going to write as the numbers between negative and 5 along with 5. So negative 5 less than x, but we can also include the 5. So I need to put my equal sign down here and then my 5. So this is this one. So a group of test scores that are no more than 90. No more than 90. So it's all the numbers that are smaller than 90, like that. The positive numbers that are a maximum of 32. So x less than or equal to the 32 can include it, and that's a maximum of 32. So here we're going to do at most 3 halves, at most 3 halves, less than or equal to 3 halves. So here's verbal descriptions. Write a verbal description of the integral described by each inequality. These are all the numbers t that are less than or equal to 3, at most 3. All the numbers x bigger than negative 10, so negative 10 as bigger than is always to the right. So negative 9.999 would be included, negative 9, negative 8, all the way through 0 in the positives. Here's the compound. 300 is less than p, all the numbers p bigger than 300, 300 not included, less than 500, 500 not included. And this last one, 0k is all the numbers between 0, zeros included, and 9. 9 is not included. So let's do some more work over here. Let's go through these, simplify each expression as much as possible. So I'm going to take a look at this one right here. I'm going to bring this over here so we can work. So I've got my 4 times 2t. So I've got to distribute the 4 across here, 4 across there, and then I'm going to group. So I need to come over here and I'm going to go 4 times 2. Well, that's 8t. 4 times minus 11 is minus 44 plus 3t. And now we've got it expanded out. We can group 8, 9, 10, 11t. So 11t minus 44. We can't do any else with that. Okay, so I draw a line. Here, 8y plus 4, so that we can't do anything with that. I'm just going to copy those over right now. I'm going to expand the next expression with the parentheses, negative 4 times 7 minus 28, and negative 4 times negative 3. 4 times 3 is 12. We have to change the sign. Negative times the negative is a plus 12y. Now we can add these things up. The 8 and the 12, that's going to be 20y. And plus 4 minus 28, opposites of signs. I'm going to take the smaller subtracted from the larger, so that's 24, and I keep the sign of the whatever the larger is, so that's going to be minus 24. So here I'm going to write down here, I'm going to say I've got to do all of this expression. I can't just drop these parentheses with this negative sign. I've got to distribute there, and I've got to distribute. So this is, let's see if we take a look at this. So I've got 10x, the 5 times plus 1 is plus 5. Now I do the negative 5x, negative 3 plus 2x plus 10, and now I can combine. All my x's, 10x, this one, and this one. 10x minus 5x is plus 5x plus 2x is 7x, and then I can do this, this, and this. And those signs are associated with these numbers. So I've got plus 5 minus 3, that's plus 2, plus 10 is plus 12. So let's look at this. Let's find some solutions to equations. Here's some simple equations. And we certainly need to be able to work these things in our classwork, our application. So I'm going to do two. I'm going to do number A, or letter A, 4A. I want to solve x plus 2 is equal to 5. Okay. So you remember we could do things like, number 1, I want to isolate this x. I want to have something like x is equal to some number n. That's our goal. So the things I can do, I want to isolate this, and anything dangling, I want to take care of that first, and I do the opposite. So I've got plus 2, I want to do the opposite, which is subtraction. So I want to subtract, and I've got to do it to both sides. So if I do it really the long, correct way, I've got this. And basically I've subtracted off 2 on both sides, and this is 0. 2 minus 2 is 0. So now I've got this here, x is equal to, that's going to give it to me. 5 minus 2 is our 3. So here, let's bring it down just a little bit more. I want to work on this one. Y minus 3 is equal to negative 10. So again, I want this time y is equal to some number. Okay. So here I want to isolate the y, leave that alone for a while, and I want to get rid of this dangling stuff over here. So I'm going to do the opposite. I've got a negative 3. I add 3, and what I do to one side, I do to the other, and that just makes that 0. So I've zeroed it out. And now I get to repeat. Negative 10, this was a negative, so negative 10 plus 3, negative 7. So that's our solution. We can check it. Negative 7 minus 3 is indeed negative 10. Here, let's put the 3 back here. So let's go over here and let's do our checks. 3 plus 2, and does that equal to 5? Yes. Here, does negative 7 minus 3, does that equal to negative 10? And yes. So here, 5x is equal to 35. And our simple, this is here is multiplication. That's understood multiplication. So there's no dangling. If there was a minus 3 or a plus 2, I'd get rid of that first. I do subtract, get rid of all that side. And then this last step, whatever this is multiplication, I do division. And if this had been division, I would do multiplication to make the following. That's going to factor out. So 5 over 5 is just 1. So here, x is 35 over 5 is 7. And then we can check, does 5 times 7 equal 35? Is that it? Yep. So we got it. P over 365 is equal to 10,000. And now in this case, I want to, this is division here. That fraction is the same thing as division. So I want to now multiply. It's really 365. 365 over 1 is the same thing. P over 365, 10,000 times 365. Cancel, cancel. 3, 6, 5, and then 4 zeros. 1, 2, 3, 4. Just like that. And if I divided that by the 365, that would be the 1 and the 10,000. Okay. So that was just some skills review. Let's continue on and get into the rest of the lecture. So they say all quantities are not created equal. Of course, you know, our equality is one thing. This is inequalities is what we're talking about. So here are some things that we're going to go through. Again, here's our practice. Name a number that makes x greater than 3 true. You remember the true statements and the false statements. 0 is that, so let's pick a 0. Is 0 greater than 3? No, that would be a false statement for x equal to 3. But other ones like 4, 5, 6 would work. How about 3? 3 would not work because 3 is not bigger than 3. If we had the equality here, greater than or equal to, then we could use 3. 3 is greater than or equal to 3. Name a number that makes x greater than 3 false. Oh, that 2, 0, 3 would also make it false because 3 is not bigger than 3. Okay. So in many ways, solving inequalities is similar to solving equations. First step we identified in solving equation was to use the distributive property and combine like terms to simplify each side of the equation as much as possible. The same is true for inequalities. Surely most folks would prefer to work with a simpler inequality rather than a more complicated one. That's the only way that you're going to be able to isolate an x all by itself, is to do the simplification first and then work with it. And here is our summary of tools that once we get this thing simplified that we can use. We can multiply the same non-zero number or expression on both sides, divide both sides by the same non-zero number or expression, add the same number or expression to both sides, subtract the same number from both sides. But here, if this is a negative number, we have got to switch the sign. We just have to switch it to make the inequality still true. So here, let's look at this. So here's some things that we can do. Add 8 to both sides. If we start here, we added 8, we get 18 is still less than 28. That would still be true. Add negative 8. If I subtract, this is basically saying add negative 8 or subtract 8. 2 is less than 12. We still get the same true statement. 18 is less than 28. 2 is less than 12. Subtract 6 from both sides. 10. Here 10 is less than 20 is true. Subtract 6, I got my 4. My 14, this is still true. Subtract a negative 6 from both sides. Subtract a negative 6. So we're going to do a double negative. Here we're going to add 6, and we're still true. So adding or subtracting the same number on both sides of an inequality does not change the direction of the comparison symbol. So here we're going to go through and some of the things that we can work on. If I have x minus 5 greater than or 9, I want to have this a simple inequality here, with x being some inequality with a number. I don't want it x minus 5 is bigger. So here I add 5 to both sides just like I did before. Get rid of any dangling things. Plus 5, that gives me x bigger than 14. And here's the picture. Draw the circle where that 14 is not included. Here's just another way of representing this. Draw the circle. That does not include 14. I could also put a little parentheses right here, open, and that would be not 14 wouldn't be included. All the numbers bigger than 14. T plus 11 is less than or equal to 5. I'm going to subtract 11 from both sides. So that goes to 0. 5 minus 11 is negative 6. Less than or equal to, all the numbers t less than or equal to negative 6. These are the left side, to the left. But negative 6 is included, and here we're using a filled-in circle to represent that, negative 6 is included, that dot. So write a verbal description of what the solution says to the two inequalities in the colored box really tell us. The first has been done as an example. The inequality of 3 bigger than x is exactly the same thing as x less than 3. In each case, the quantities that is less is on the closed end of the comparison symbol, but we'll almost always write x less than 3 with the variable to the left. All the numbers x greater than, but it's certainly okay to do either way and then switch them, just switch both numbers. Okay. So here, any value of x greater than 14 will cause x minus 5 to be greater than 9. Okay. So here they're saying any value of t less than or equal to negative 6 will cause t plus 11 to be less than or equal to 5. So here they've subtracted 5 from both sides, so x minus 5 would be greater than, if x is greater than 14, x minus 5 is greater than 9. So you can still work and build these things up in a backwards way. We usually start here and then work backwards. So here, t less than or equal to negative 6 will cause t plus 11. So I'm going to add 11, less than or equal to negative 6 plus 11 would be the 5. Again, here's our multiplication. So here's 2, and if I have 10 less than 20, a true statement. If I multiply by a positive number, 20 is less than 40, so that's still true. Here, though, I'm going to do by negative 2. I started with 10 less than 20, a true statement. But when I multiply times negative 2, I've got to, here's my negative 2 times 10 is negative 20. Negative 2 times 20 is negative 40. But notice that negative 20 is not smaller than negative 40. I've got to change that sign, the direction of the sign. Division is the same. Divide by the same numbers. Positive, I keep the same symbol side. 10 divided by 5 is 2. 20 divided by 5 is 4. Still 2 is less than 4. But here I'm going to do the same thing I did above. I've got a negative number. 10 divided by negative 5 is negative 2. 20 divided by negative 5 is negative 4. But that division by the negative number or multiplication, I have to change this direction. Negative 2 is actually bigger than negative 4. Negative 4 is to the left. All the left numbers are smaller. Okay. So if you multiply or divide both sides of an inequality by a positive number, the direction of the comparison symbol stays the same. If you multiply or divide both sides by a negative number, the direction of the comparison symbol changes. You have to switch the direction. And here's the, we started out with this direction. I divide by 2, still the same direction. Here I'm dividing by negative 3. I've got to actually change the direction. So it was greater than, it is now less than or equal to. Okay, just like we did equalities, we've got a summary of the steps. Simplify both sides of the inequality if necessary by multiplying any parentheses and combining any like terms. Use tool number 1 to raise the inequality so the terms containing the variable is isolated on one side. And then number 2, so this is the addition, subtraction, multiplication, division to change the coefficient of the variable to 1. Okay, so I hope you found that instructive. We'll work on some more of those things in lab. Have a good day.